Hello, good morning. We're going to start with a problem string today, and then we're going to learn a new game. So grab your journal and we'll get started. How about that one? Good work. Oh, my camera's struggling this morning. All right, so how can you use that to solve this one? So the only difference between this problem and this one is this extra 0 to the back, which means we times it by 10. So if the put a 0 to the back here, all I'm going to do is put a 0 to the back there. So what about this one? Okay, so you could use your 3 strategies here, which is doubles plus 1 set. So 6 doubled is 12, plus 6 more gives us 18. How can you use that to solve this one? Okay, so once again, they put a 0 to the back, which is times 10. So all you're going to do is put a 0 to the back there. So how can you use all this information you know to solve that one? The only difference here is adding one more set. So you're going to take your same answer from above and add 3 more to that. So that's where you end up. How about that one? So this is subtracting a set. So you can come from here and take 180 minus 3. So it's one less group. Can't do that, so you come here. This becomes a 7. So 10 minus 3. 7 minus nothing. 1 minus nothing. Much easier than having to start all the way over. I did notice on a couple of our skill checks that the concept of double and halving is really confusing, so I wanted to spend a little time kind of looking through that as well. So I'm going to draw a line over here. 4 times 3. Solve that one. Okay, so 4 times 3 is 12. I'm going to grab a couple of colors here while you solve that one. Okay, so I'm looking at the two problems here. All that's different is I've doubled. So because all that's changed within the problem is doubling, my answer is going to double. So I get 24. So how about 8 times 6? Okay, so you should have solved this. When you're looking through this problem, the only difference is this one has now doubled. So once again, this is the same. This one has doubled. So my answer is going to double. How about that one? Okay, so this one has two things going on here. This one has doubled. This one has halved. So because this one is half and this one is double, they're technically crossing each other out, which means my answer is going to stay the same. So if I had a problem that said 8 times 6 equals 4 times what, which is what you had on your expressions number skill check, it didn't want you to solve the problem. It wants you to see the relationship between the two. So if I'm looking at this problem, I can already see this is halved. And if I want those expressions to be equal, that means this one has to double. So my answer would have been 12. So we're going to do some more work with that. So how about, I'm going to write the last one in here. So 4 times 12 equaled 48. So how about solving 2 times 24? Solve that one. Okay, we have the same thing happening again. Here, we have doubled. Here, you have halved. You've divided by 2, that's halving. So, if the problem looks like 4 times 12 equals times 24, again, just like the problems you saw on that last skill check, I would want to take a look at this and see there's got to be some kind of number relationship in here because the directions told you not to solve it. So if I'm looking, I can see right here, this is a double. If one is a double and they're equal, this one has to be a half. So half of 4 is 2. So I'll record that last one here. 4 times 12 is 48 as well. So then, how about, oops. So your answer was the same. So 2 times 24 was 48. So 1 times 48. What does that one equal? Okay, so there's another half. There's another double, which means my answer stays the same. So I'm going to show you all the problems from that number string in one nice pretty line here so you can see the connections we have. So we can see this whole line has divided by 2. We can see this whole line has doubled, which means that all these answers are the same. So keep in mind, just because on this particular string of numbers, the halving is always before the doubling, does not necessarily always mean it's true. I could go the other way as well. This could be the double and this could be the half. But what I'm trying to get you to see is in these problems like this, look at the two sets of numbers, the back number and the back number, right? If something is doubling, the other should be halving. And that's how you find those number relationships. And then when you're explaining it, you would say 12 doubles to 24, so 4 has to half to 2. All right, let's go learn our new game. So this is our new game called the multiples game. You can play it against yourself, or you can play it against somebody in teams or against somebody at home. So the way this game works is the first person picks any number they want on the board besides number 1. You can't pick number 1. So you can either use these little tally markers, or you can use the pencil. So I'm gonna pick 10. Then person 2 gets to pick all the factors of 10, all the ways to make. So if you look at the card I just popped up, and if you forget, those are right here, so you can look up what those are. Factors are ways to make. So how can I make 10? Well, I can make 10 with 1 times 10. I can make 10 with 2 times 5. I can't make it with 3. I can't make it with 4 or 6 or 7 or 8 or 9 with multiplying. Remember, so factors with multiplication. Remember, this looks like area or the base of our volume that we've been working with. So it's length times width, right? 2 sides times each other, just like with our area model. So multiplication is with factors or with multiplication. So then the green player gets to pick another number. I'm going to pick 11. And now the blue player gets to pick all the factors, all the ways to make 11. Well, guess what? 3 can't make 11. 4 can't make 11, nor 6, nor 7, nor 8, nor 9. Only 1 and 11 can make it 11. So that's called a prime number, when only 1 in itself can make that particular number. So blue doesn't get any turns. Blue now gets to pick. We'll go with 13, make it a little more even. 13 is also a prime. So because 1 is already chosen, green can't pick it again, nor can blue, because it's already picked. So green gets to pick a number. We'll go with 12. So blue, 1 times 12 is 12. 2 times 6, 6 is open, is 12. 3 times 4 is 12. 7 cannot, 8 cannot, and 9 cannot. Okay, so then blue gets to pick another number. Let's go with a big number. Let's do the 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. So those are all the choices. Okay, so green can pick another number. How about 22? So 1 and 22, 2 and 11. Nope, that didn't work. Okay, sorry, blue. Blue takes 21. So 3 and 7. And then 1 and 21, but those are blocked. Okay, so green. I'm going to take 28. So 1 and 28, 2 and 14, and 4 and 7, but those are all blocked. So about 29. 29 is also a prime number, meaning it's only made with 1 in itself. So green does not get anybody. Green's gonna take 26. So 1 and 26, 2 and 13. But those are taken. So blue's gonna take 27. 27 is 3 and 9. 1 and itself. So green, how about 25? So 1 and 25 and 5. Oh, that didn't work out very well. How about 23? 23 is also prime, so they don't get anything. So then 24 has a lot of factors. So 1 and 24, 2 and 12, 3 and 8. So blue gets 8. And 4 and 6. All right, so blue, gonna take 20, which all the factors are pretty much filled in by now, so it's kind of just a back and forth game because 16, 17, 18 can't make each other. Okay, I've also attached another website to here that gives you all the factors for 1 through 30, so you don't have to do it off the top of your head, so don't feel stressed out about that. I will show you that at the end of this. So now that all the spaces are filled up, the next thing you need to do is to add all your numbers for your color. So all the blues get added together, all the greens get added together, and whoever has the highest score wins. So real quick, I want to show you that other website I'm going to have for you. So here is that. So the way this works, you're going to be focusing mostly on this side. So the purple is the 1 through 30. So if I was looking for the factors of 9, this side is factors. So 1 and 9 and 3 times itself, which is why it's only on there once. Then multiples, that's skip counting. And I can see all the way through 10 on the other side. This is a pretty cool website. So if I scroll down, here's an example of a prime number, 31. Only 1 in itself makes it. If I look at 30, 30's got a lot of factors. 1 and 30, 2 and 15, 3 and 10, 5 and 6. So this is how factors are listed for numbers. So this would be a prime, and this would be a composite. Composite is a very long word, lots of pieces, meaning lots of ways to make. Prime is very short, 1 syllable, 1 way to make. Let's go and jump back to our game here. There we go. So then you add all these numbers up, and then you'll know who's the winner. If you get stuck or forget how to play, remember that first page always has the directions, and have fun playing, and I'll see you tomorrow. Bye, guys.